Hello everyone, same day. I'm probably gonna drop these videos 2 different days. Maybe the same day. We'll see, but it's the same day that I filmed the radical video. This is not everything you need to know, but enough that will get you by on the topic of logarithm and logarithmic expressions in Algebra 2. Because I don't know everything in this. I don't know even probably most of it in this topic. Because again, I'm taking a 7, maybe 8 week course. But I'm going to tell you what I know and what you definitely need to know. Maybe majority of what you need to know. We'll see. So first, what are logarithms? Essentially, all they are is the inverse of an exponent or an exponential function. So I'll write it out on a piece of paper. Yeah. So if you have the exponential formula or function saying that y to the x power is equal to z, that means that y multiplied to itself x times equals z. So in order to find the inverse, just like during equations, you get the inverse of multiplying by dividing or of adding by subtracting. You have to use an inverse function to figure out what each of the different things are. So you'll usually be given 2 out of the 3 of these, maybe not. So you'll be given like the y or the z to figure out the x by using a logarithmic expression. And so I'll write it in the logarithmic format. So you're just trying to find the inverse of this, pretty much. It is written like this: log base y. I don't know if it's multiplying. I think it's just z, or maybe it's multiplying. So it's log base y z equals x. That's saying that log base y, so logarithm base y, that's this, to the x power equals z. So it's more of a question. It's asking how many times does y multiply times itself to get to z? And that equals x. So sometimes you'll be given the y and the z, and you have to figure out what the exponent is. You'll be given the x and the y, and you can try to figure out what the end goal is. That's just the main thing, the main summary of it and what they are. And so when you're graphing these, literally how you just find the logarithmic, the inverse of an exponential function, and I'm hoping you know how to graph an exponential function if you're on here, is you just switch the x and the y values. So it'll be just an inverse function. So if you have your exponential function going like this, the inverse will just be going like this, So that's not hard when it comes to graphing. I forgot my microphone. So really, if you understand what exponents are, logarithmic equations aren't hard when you have actual numbers in place, because most of the time you know how to solve them and how to formulate them and how to make sense of them in your head. I'll write out an example. Okay, so if you have log base 2 8 equals 3, all it's saying is that 2 to the third power equals 8, which we already know, right? And so it's really not hard to identify what is what in these equations. Once you get the hang of it, it becomes quite simple, actually, until they start making actual equations with adding and subtracting and dividing and that kind of thing. But we'll get into that in a second. Some other things that tripped me up was the special bases. And so, like this, instead of having the base be 2, the assumed base for all logs are 10 for some reason. And so I would see just log and then a number equals that written out. And so if it's not written what base it is, it's assumed to be 10, which always confused me. You're also introduced to a number called e, or a constant, if you will. It's like pi. I don't know what it is, really, other than it's always positive, and it's like 2.7 something, but I don't really know actually what it is, because pi is like this area of a circle or whatever. But I don't really know what E is, but E, the inverse of E, so E is just some random constant, and the inverse of it is log natural, so ln, which is just a natural log. I'll come back to you on that. So yeah, ln just basically means, it's just writing log E. So I'm not really sure why we use E. There's not, you'll just end up putting in a calculator and get some random decimal when you use it. So it's, I don't know, it's confusing. But if you see E, you just gotta kind of multiply it by what E is. So if you see ln to the E, or ln base E equals 1, then E to the first power, oh, okay, hold on. So ln base E to any power just equals whatever that power is. Wait, that doesn't make sense. I don't know. This is what Gemini is telling me to do. On to our next topic. There are a bunch of properties in this that I have to write down, and I have a whole bunch of different formulas on my wall to look at during assignments and things, so I can remember what's, because there's so many different formulas, and they're just different slightly, or maybe they're different completely, and there'll be different formulas within formulas and stuff like that. And so there's like the product property, the quotient property, the power property. These all, I can go into them. I'll go into them. The product property is just saying that any log base and then times two different numbers, as long as the base is the same, is equal. Here, I'll write it out. Actually, I already have a card about it. Saying that any log with a base that's the same times two numbers is the same as just adding them separately. So as you can see, log base b xy is equal to log base b x plus log base b y. So I just think of it as, if you see it multiplied, you can add it. I'm not sure why that happens, but it makes it a lot easier with equations. There's the quotient property that basically just turns division into subtraction. So if you have a log with base b times x over y, that's the same as log. So since the log base is the same, the only thing that's changing is the product. And so log base b x minus log base b y is equivalent to log base b x over y. And there's a power rule, which basically just states these are for all when you're expanding equations. These are the condensed versions, and like sometimes it'll be asked to expand equations or condense them. This side is for condensed, like this is the condensed version, this is the expanded version. I prefer the expanded version, like I explained in my previous video. So the power rule, power formula, property states that if there's a exponent on this thing, that you can just move it to the front of the log. I don't know why, but again, makes it easier, because it's hard when you have log bases or with exponents. So you just can move it, and it makes it easier when you're expanding things. Next, we have the change of base formula, which is so complicated to me. So the change of base formula allows you to rewrite a logarithm with any base into a fraction of logarithms with a new base. So when they're equations adding two different logarithms with different bases, you can't do that since they're like not the same thing. It's like trying to add 2/10 to 5/4. You just can't add them because they're not the same denominator. So you have to make them the same thing before you add them. And so this is written out. I'll have to write this down and put it on my wall because it's not my wall yet. After extensive research, I figured out what the log base change formula was. This is good for me and it's good for you too. So basically, if you have a, say, log base 3, 5, and try to evaluate it, you won't be able to, because even if you figure out some way to do it in your head, a calculator won't compute it. I don't know why they don't make calculators that let you do it, but here we are. They just want to do it the hard way, I guess. So the only log base calculators will calculate is log base 10 or ln. And so you use your handy dandy this thing to figure out something. Hold, please. Just to find what the exponent would be. This is what you're trying to figure out. And so you take log base c, and c is whatever you want it to be. Usually c is 10 because you want to get it to be 10 so you can plug it into your calculator to make your life easier. So typically c, log base c, is going to be log base 10, or otherwise just known as log. And then multiplied by a, which is your argument, which is kind of hard. It is just this is a. So this is your original thing. So it's like, say you have log base 2 35. So it's log base 2 35. So you're trying to figure out how many times 2 multiplies to itself to get 35. But you can't do that on a standard calculator because it doesn't allow that to do that. And so you take log base 10 times that number, so 35, divided by log base 10 times your base. I don't know why the formula works, but it does. And it'll give you 2, so then you plug that in. So once you have log base 10 anything, the calculator will allow it, and it'll calculate it. So you'll get some random long number there, and then someone down there, and then you divide it, and that'll give you your exponent. Easy as that. Took me a while to figure out too. Oh, I forgot about this. Keep forgetting about it. So next is graphing. Graphing for this is not much different than graphing for exponential functions in Algebra 1, if I'm being quite frank. Hello. I just ate dinner, which is why it's dark now. So let's get back into it. So like I previously stated, logarithms aren't much different than exponential functions when it comes to graphing. Yes. So their main things like asymptotes, which is just a line, a dotted line that indicates where the exponential function will approach but never meet. So usually it's 0 for normal growth or decay functions that are going like. So obviously if there is a growth function or we'll say a decay function. So if you start up here in the negative positive in the quarter 4, so up here, or it'll be mirrored, so like up here, right, and maybe it's up here, and then you go down as you go, as the x value increases, the y value decreases, it'll approach 0, but it'll never meet 0, and so that dotted line indicates that, and it's called the asymptote. Transformations, it's the same as it was in Algebra 1, not much different. Domain and range, again, all these things are concepts you already are familiar with, you just do it for the inverse of exponential functions. And so there are also different kinds of exponential functions when it comes to like compounding for things like interest, mainly and pretty much only money word problems. There's normal, like natural, like just normal interest. There's compound interest, and then there's continuous compound. I'm going to show you the differences between them. Then I think this is the last topic. So first you got normal, which is just your run-of-the-mill. You have 20 grand. You get 5% interest each year. How much do you make in 10 years? And then you just, do the y equals your initial money times 1 plus, like the percentage in a decimal form, and then to the power of time. Compound is when you say you get 5% interest, but each month or something like that. So like time matters and small increments of time matters. So like the time will be added on. So if you get 5% each month, how much do you get in a 7-year period, right? So that is modeled by y equals the principal or the initial value times 1 plus the percent in decimal form over your increment of time, I believe. So if it's a month, it'll be 12, and then times increments of time times years, I believe. Next is continuous compound. And that is modeled with our fun little letter e here. And so we have y equals the principal or initial value times e to the percentage times time value. And for that one, I saw a video on it. It's basically like if you have compound continuous interest, it's where you are charged, say you're charged monthly, your interest is charged monthly, but each time since your interest or your value is going up each month because you're gaining more money, the interest also increases because so like so you have 20 grand at the beginning of the year, right? Month 1 you get 5% interest, so you now have 1.05, or you have, say, well, I don't know how much that would be. What's 5%? So you have $21,000, but since you have $21,000 now, February's interest is going to be more money because it's 5% of that 1.05 amount of money, if that makes sense. And so you have your fun little letter E, you can just plug that in a calculator, and it's kind of like your job's really done. And you should remember the formulas, and you'll be good. That's pretty much what you need to know for logarithms in Algebra 2. If I forgot anything, please let me know. But no one and their mother are going to be watching this video because it is currently June 10th, June 11th, June 9th. Damn, okay, June 9th. My bad. So yeah, see y'all soon. By soon, I mean August 4th in the pre-calc classroom. You already know.